we're going to be doing a much harder example of an assembly program. This program has everything. It has a for loop, a while loop, it has an if-else statement. So in order to tackle this on, what we're going to do is we're just going to do things line by line. We're not going to think too far ahead. We're not going to think too far behind. And in order to not have to worry about what registers we can and can't use, we're going to decide to store all our variables into memory, aka into labels. That way we don't have to think about, oh, register 0 was supposed to store I can't use that. Register 1 was supposed to store digit, I can't use that. And that way none of our registers are clogged. And now we can use all our registers as scratch work. And this actually really just lets you turn your brain off and do things line by line. It really helps you when you don't have to worry about which registers you have and do not have. So anyway, without further ado, I want to mention we have a string here. And these strings, you can just treat them just like arrays of characters. And like with all arrays, we're going to need to somehow get the root address of an array. And the root address of an array is just the address of the 0th index. So that's explicitly given to us here. So we can just load that in whenever we need it. And time to begin. So string hex string to int equals a9ab. That's already been done for us over here. We have int length equals 4. It's already done for us here. Int value equals 0. So that hasn't been done for us. So we can make a choice here. We can make something like this, where we can just decide R0 is going to represent value. Or what we can do is we can use a label to store value. I'm going to pick this way. That way I don't clog my R0 for the rest of my program. And I can use it freely. And so this value label just basically represents my int value up here. And this .fill0 is basically just initializing it to 0 to start my program. So we actually don't need to do any LC-3 assembly lines of code. That was just an assembler directive. Next line of code, for loop. First thing to do is just copy paste your template. Right. So loop initialization here. That's going to be this part. I'm going to follow a similar process with int value equals 0. I'm going to use a directive instead of using instruction. Make my I variable and .fill that with, looks like it must be initialized with 0, so we'll just .fill 0. That's already done. Now we got to prepare the condition code. So to prepare the condition code, alright, we need to get our condition code to be based off this comparison. And in order to do that, we need to make sure it's a comparison to 0. We'll subtract both sides by length. Now it's a comparison to 0. And to prepare the condition code, all you have to do is to get any register to be set to this value, I minus length. You don't got to store this value anywhere or do anything fancy with this value. All you got to do is just get that value into any register, and then you're done with preparing the condition code. So I'm going to comment this out. I'm trying to get I minus length, any register. So start with load our I into register 0. Load our length into register 1. And we want to get negative length. So in order to do that, we can use choose complement. So we're going to flip all the bits and bitwise not it. And after you flip the bits, we're going to add it by 1. Now we have negative length. Just add I and negative length together. Now we have I minus length in any register, and that completes our condition code. Almost. Let's have to do pick which cases are our branch on failure. So we have I minus length is less than 0. So in order to, the opposite of this is going to be greater than or equal to. And greater than or equal to 0 is the same thing as 0 or positive. So those are going to be our codes that we're going to pick for our branch on failure. Alright, now we're done with the condition code. We can start to loop body. So okay, I have an int LeftShifts variable 4. And I'm gonna do a similar thing. I'm gonna make this into a label. I want to initialize with 4. But there is a caveat here. So notice this int LeftShifts equals 4. I mean, it has to get reinitialized every for loop, right? So this .fill thing, it only really does it once at the very beginning of your program. So it's suitable for these variables that only need to be initialized once. But this LeftShifts 4, I can foresee it will need to be reinitialized every loop. So this .fill is not going to cut it. So what I'm going to do is I'm going to need to use an instruction to explicitly set this to 4. I can do that by just anding R0, just clearing it with whatever it had before, because I don't really care what I had before. And I'll add 4. And I'm going to store that 4 into LeftShifts. So this just manually reinitializes our LeftShifts 4. Great. Now next line of code. Looks like we stumbled upon a while loop. So I'm just going to copy paste the template. Alright, so we need to prepare the condition code first things first. Looks like that's the first bracket we have. Condition code is going to be based off this statement. So in order to prepare the condition code, all I got to do is get a register that's just equal to LeftShifts. Any register, it doesn't even matter. Once that register has a value of LeftShifts, then I'm done. So and I can do it with one line of code. I can just load R0 with LeftShifts. And that's it. And what should I pick for my code? Well, opposite of greater than 0 is less than or equal to 0. And less than or equal to 0 is the same as negative or 0. So I'm going to pick NZ for my code. And that's it. So now I'm going to go loop body. Like value plus equals value. First line of code. I can do this in a nice way. So I can just load R0 with value. I'm going to add it with itself. This basically doubles R0 because it's saying R0 equals R0 plus R0. I can store it right back in the value. Alright, line of code's done. LeftShifts minus minus. So I can do that by just loading LeftShifts into any register. LeftShifts. Subtracted by 1, it'll store it right back. Done. Now we ended our end while part, so looks like that's it. There's nothing more for this while loop. So we'll continue line by line. Int CharDigit equals octal string I. Alright, so you can think of this end bracket as end while no op. So this line of code should be below that. CharDigit equals octal string I. So how can I get this line of code done? Well, so this is an array. So the first thing we need to do is, our plan is, step 1, we need to get the right hand side. So in order to do that, we need to get the root address of octal string. Step 2, to add I to that root address. Then I'm going to load the value of root address plus I into a register. That's really it. So we'll start with step 1. We'll load root address, and this has been explicitly given to us. Hex string. This is actually outdated. This should be called hex string. This is a bad name choice. I'm gonna name this hex string. Alright, yeah, that should be good. So what we're gonna do is we're gonna load hex string into R0. Great. Good. And then we're gonna load I into another register. So I. We're gonna add them together. Then we're going to load the value of root address I into a register. And I'm just going to load it into itself because I don't really need what's in it anymore. And what I call it load it into itself because what this line is doing is just saying R0 equals memory R0 plus the offset of 0, which is the same as just saying R0 equals memory of R0. You're just loading this address into a value, like straight up right into itself. And now I have the value of hex string I in R0. So what I can do is I can just store that char digit. So I don't have a char digit variable yet, though. So I'm just going to set it for this char digit. And there's nothing, I have to initialize it to something I calculate at runtime. So there isn't really, I'm just going to do blockword1, which is the same as .fill with the value. Blockword1 is the same as like .fill something. It just leaves it as garbage data, so it doesn't like initialize with anything. In fact, I can even do that with LeftShifts because I do have to set LeftShifts at runtime with this for loop. I need to reinitialize it every loop. You can do that with LeftShifts as well. So CharDigit, I'm gonna store that right into CharDigit. And that's really it. We're done with that. Alright. That's how you work with arrays. Because I have an int digit variable, and we want to leave that uninitialized. So we're going to leave that as garbage data. Store that digit. Dot block with 1. That line of code is done. Now it's this line of code. And I'm going to foresee a little bit ahead, and it looks like it's an if-else statement rather than an ordinary if statement. So I'm going to use this if-else template right here. Here condition code here. Condition code is based off this. So what we need to do is we need to get this on -64 both sides, 0. And there's multiple ways you can do this. So first things first, you need to load CharDigit to the register. And then -64 part, I can do that. There's two ways to do that. If I want to do it kind of elegantly, I could just do like minus, basically like a constant label. I could just fill that with -64. And I could just load R1 -64. And I can just add them together. You could also just, instead of doing this loading thing, you can just do like something like this, -16, and copy paste it like 3 times or something. I remember you only have 5 bits, so -16 is where you go. I'm gonna do it this way though. So you're done. We already loaded the condition code. Now I gotta pick our branch condition. So opposite of positive is 0 or negative. So we pick NZ for my else. So now if body, let's find where that is. Code's getting pretty long. Digit equals CharDigit 55. I'll just do something like that too. getting pretty liberal with my labels. So I'll load digit, or no, load CharDigit. So you really are, most of the time you want to compute the right hand side. You don't really need to load in the left hand side, you really just need the right hand side. Because you usually want to store to the left hand side. Load CharDigit, R0, and I'll load minus 55, add them together. And then I want to store that into digit, so I'll just click ST for 0 digit. Should be done. That's only line we have in our if. I gotta do the body. Similar process, I foresee me the minus 47, I'm just gonna get 48. Dot fill 48. Just load R0 with CharDigit. Minus 55. And I'll add them together. I'll store that into digit. How great is that? I think that's last thing or else. Then we'll have value plus equals digit. And I've noticed that's below this else bracket. That closing else bracket corresponds to our end if no op there. So I'm going to place that right below it. Value plus equals digit. So this is, I do need to load value in. It's not because it's on the left hand side, it's because this is actually the same thing as value equals value plus digit. So I need to load value in a register just so I can add it to digit. Digit 1, store that right into value. Okay. Next line of code. Looks like we're done. And now we've reached the end of our for loop. I've kind of been delaying this loop update statement. You really could have done it at the beginning if you wanted. I'm just going to do it now though. This is I++. In order to do that, I'll just load R0 with I. The reason why I need to load is because it's I plus 1. I have to load it to get this I. Add up 1. Store that right into I. That should be done. So, done with our entire loop. This closing bracket corresponds to this end for. And so the last line of code is mem result equals value. And the pseudocode doesn't know if you're choosing to use labels for these values or if you want to use registers, so it just leaves them as is. That's why there's no like a mem value plus equals label or something. But so that's why it explicitly has this mem result equals value. What I'm going to do is I'm just going to, I need to load value in any register, and I can just store that into result. And that should be our whole program. So yeah, it was kind of scary, but we just did things line by line. And the hardest part is making the pseudocode. But for all of your assembly related things in this course, we're going to be giving you the pseudocode. And so you can just turn your brain off and just do things line by line. As long as you know how to implement each line individually, you just implement it individually. And at the end of your, after you just did every line like one at a time, your program just manifests like naturally. That's the idea behind assembly. Alright, so I also want to cover a little bit about storing into an array. So I just added this line of code here in our pseudocode. And also I made a fix, I think I had a bug in my code. This was supposed to be minus 48, now minus 55, but I fixed that. And the change that I did was I got this .org x5000, did a block word for, reserve 4 spots. This is going to be representing my intermediate array. also given myself direct access to this root address of this array. It's pre-computed as x5000. We'll start with that. Get this line code. Very end of my for loop and add this in. So in order to start, well, first things first, I need to get value in the register. So just load that register. And now we need to find out what address we need to store this value at. I guess I'll write the steps down. So the address is going to be basically the root address of this array, and I have to add I to it as my offset. So step 1, get right hand side into register. Get root address. Another register. Step 3, get add root address plus I from probably this register, and then use root address plus I as second param to str with offset 0. And so sometimes if you didn't have an I, sometimes you had like a fixed offset like 3. You can't just skip step 3. You can do the adding with the offset. But because we're using a variable offset like with I, we can't use the offset part of str. We have to manually add the offset in a separate line and just set the offset to 0. So we're basically doing computing the offset in advance and then just using 0 always. Anyway, so have my intermediate array root address pre-computed at this label, so 5000. So need to add that with I. I'm actually going to use R2 to get I into register. And you're probably wondering, wow, you're actually using R2 for the first time. I could have gotten away without using R2. You really only need 2 registers to make any program. One example is I could have actually just loaded this into R0, load this into R1, and add them together. And so do the array calculation first. So, but I'll use R2 just to show that, yes, I can use more than 2 registers. I can really use all 8 for homework 5. And homework 6, you can really use up to use 5 registers for your intermediate calculation. Oh, what am I doing? That's gone. And I'll add R1, 2. So now I'm getting intermediate array plus I. That is step 3 done. Now I can use this root address apply as my second parameter to str with offset. So I'll load the value 0 at R1 offset 0. That's actually it. So that's how you can store into arrays. Hopefully that helps. Alright, so I also have to prove that it works. So Complx and so interesting. Oh, it's a typo. Okay, let's try that. Okay, so I run my program. So first things first is that I'll show what I do is I click on view, hide addresses. I'm only going to show code/data. Notice everything below 3000 is hidden, unimportant. And this is all my code. These are my labels. And notice I get a huge jump to 4000. This 4000 is storing my string. These 4 characters are my string. I get another jump to 5000. And this is supposed to be my intermediate array. I run my code. I get 8, 89, 89A, 89AB. And see, told you, isn't that kind of cool? And I guess 89AB is a little bit too big. Because 8 is 1000 in assembly. So it's saying it's negative right now. I'm actually gonna rewind it. Let me change that to change this 8 to a 7. 55. Hopefully if I run it. Yep, you get. So if you take 7, 9, AB in hex, you convert it to an integer, this is what you're gonna get. 31,147.